Hi everyone. So this lesson is called the remainder and factor theorems. And so basically what we're going to be doing is we're going to be given a polynomial and we're going to be asked to find all of the factors and the zeros. And so we've kind of been doing that already, except I've been giving you ones that are kind of easy to factor. And so we're going to be given now polynomials that maybe are not factorable. However, we give you a factor of it. And so what we're going to do is we're going to use synthetic division to find the others. So first, let me just do a quick recap of synthetic division. You guys are pretty good at it. So let's see if we remember. So remember with synthetic division, there's first a number in a box. The number in the box comes from the divisor. You take the opposite sign, which is going to be positive 3. Remember, because this binomial is called the factor of the polynomial. And then this, the 3, is the 0 that goes with the factor. So we have factors, we have zeros. Zeros are the opposite sign of the factor. So the number in the box is really the 0 for the factor. Then you put all the numbers, the coefficients of the polynomial. So we're going to have 1, 4, negative 15, negative 18. And you draw a line, then you drop the first number below the line, and you multiply and add and multiply and add, and you keep going until you're at the end. So 3 times 1 is 3, 4 plus 3 is 7. 3 times 7 is 21, negative 15 plus 21 is 6. 3 times 6 is positive 18. So then you add those together and you get 0. Remember, when you have a remainder of 0, that means that x minus 3 is a factor of the polynomial. We talked about that. Now, if you remember when we learned this, we were dividing. So our goal was to get a quotient, right? We still want that. Do you remember, hopefully, that these 1, 2, 3 numbers turn into a polynomial? That polynomial is called the depressed polynomial. I'm not sure if I ever actually defined that for you, but that's what it is. The depressed polynomial is the polynomial you get after doing synthetic division. So the polynomial you get after synthetic division. So this one would be x squared plus 7x plus 6. It's called the depressed polynomial because remember how the exponent is determined by going one down, kind of like depressed down, 1 down from 3. So that's why it's 2. So that's the depressed polynomial. So what we're going to do in this section is we're going to use the factor theorem, the fact that this is it in like normal language, that a binomial is considered a factor of a polynomial if the remainder is 0 after dividing. So anytime the remainder is 0, you can take that depressed polynomial and you can find more factors. So that's what we're going to do in this section. So we're going to each time be given a factor, be given a polynomial, asked to show that it's a factor, and then find the remaining factors, and then lastly identify all of the zeros. So you start off with doing synthetic division. The remainder has to be 0 in order for this to be a factor, which we're told that it is a factor. They're saying show that it is a factor. So you should always get a remainder of 0. If not, something went wrong. Okay, so we first put the number in the box, which is going to be the 0 for this factor, which is 5, opposite sign. Then we write out our numbers, 1, negative 7, 7, and 15. So we drop down the 1. 5 times 1 is 5. Negative 7 plus 5 is negative 2. 5 times negative 2 is negative 10. 7 plus negative 10 is negative 3. 5 times negative 3 is negative 15, and then that's 0. So yes, this is a factor, which we already know because it said show that it is. Now we need our depressed polynomial. X squared minus 2x minus 3. So step 2, after we do synthetic division, says use the depressed, I was trying to underline. Use the depressed polynomial to find the other factors. We're factoring. So we're going to factor this polynomial now. This is a trinomial where a is 1. So we want two numbers that are going to multiply. We want multiply to negative 3, and we want add to negative 2. So it's going to end up being, let me switch back to blue, negative 3 and positive 1. I don't know why this is so far away. There we go. the heck, man? What's happening? There we go. Okay, so now we write our factored form. Now, when you're writing your factored form, you want to remember that this original one was one of the factors too. So you want to include factor from original. Don't forget that. So my final factored form, I have the one from the original, x minus 5. I don't mean from the original. That doesn't even make any sense. From the given. Or maybe original did make sense. I don't know. But from the given information. That's one of the factors. And then these two are the other ones. And then we know how to identify zeros, right? Just opposite sign for each one. You don't really have to worry about putting multiplicity because we're not graphing them. If you did have one that came up twice in multiplicity 2, then yeah, you might want to mention it. But otherwise, it doesn't really matter. So that's it. We do synthetic division, we get our depressed polynomial, we factor that, and then we get our zeros. Pretty simple. Let's look at the next one. So again, we start with synthetic division. So here's our first factor, which, excuse me, the 0 for that is going to be positive 2. And then we write out our coefficient. So 1, negative 7, 4, and 12. We bring down the 1, we multiply, we add, multiply, add, multiply, add. So there we go. Our depressed polynomial is x squared minus 5x minus 6. Again, we just want numbers that multiply to negative 6 and add to negative 5. It ends up being negative 6 and positive 1. A pretty common answer today when I taught this was negative 2 and negative 3, which would add to negative 5, but would multiply to positive 6. So it's not quite that. Okay, so our final factored form, we take the one from the given. So we have f of x equals, we're going to have x minus 2, x minus 6, x plus 1. So our zeros are 2, 6, negative 1. So that's it. This next one, the factoring is a little trickier. So you'll see number in the box, negative 8. And then our coefficient is 3, 14, negative 72, 64. Bring down the 3, negative 24, add together negative 10, multiply, add, multiply, add. So yes, it is a factor. So our depressed polynomial here is going to be 3x squared minus 10x plus 8. Just kidding. So notice this one is a little bit different than the other ones. The other ones had a leading coefficient of 1. This one has a leading coefficient of 3. Anytime that happens, you want to first try to see if there's a GCF you can take out. If there is, take it out. This one does not have a GCF. So that means that it's a trinomial where a is bigger than 1, and you have to do box or grouping. We haven't done a lot of these, so hopefully you remember what to do. For box or grouping, I'm going to do box because most of you have chosen box method as your favorite. But either way, the beginning steps are the same. You multiply 3 and 8 to get 24. You think about numbers that multiply to 24 and add to negative 10. It ends up being negative 4 and negative 6. Then you make a 2 by 2 box. I'm going to do that over here. Your first term, 3x squared, goes in the top left. Your last term, 8, goes in the bottom right. Then you take your negative 4 and your negative 6, and you put them in those boxes, and you throw an x next to it. Then you identify the GCF of each column and each row, and you write them where I put those dots. You pay attention to the box that's closest to the dots, and that determines the sign of the GCF that you're going to write. So 3x squared and negative 4x, the GCF is going to be positive x. Negative 6x and 8 is going to be 2, but since this one's negative, it's negative 2 that we write. 3x squared and negative 6x is 3x. Negative 4x and 8 is going to be negative 4. Again, negative because this one's negative and it's closest to it. So then these become binomials. So watch when we write out our factored form. We have f of x equals, then we have the original one, x plus 8, x minus 2, and then 3x minus 4. Now you may be wondering, how do I write a 0 for 3x minus 4? Well, first let's list the other two. We have -8 and we have 2. Now, if you remember, when we first learned how to identify zeros, we talked about the reason why we're taking the opposite sign when we go from a factor to a 0 is because we're really setting that factor equal to 0 and solving for x. Subtract 8, you get -8. Hopefully you remember that. If not, there it is. That's why we're just taking the opposite sign. So when you have something in front of the x, you can't just simply take the opposite sign and say it's 4. It doesn't work. So what you have to do is you have to figure out what it is by writing the equation, setting it equal to 0 and solving for x. So I'm going to add 4 to both sides. So then you'd have 3x equals 4 and then divide by 3. So then you get x equals 4/3. So that's your last one, your last 0. A lot of times kids end up being able to do those in their head too, because you can just picture taking this, add 4 to both sides, divide by 3, 4/3. Okay, last one, number 4. This is another easier factoring one. So we're going to put our number in the box, -4. And then we're going to have 1, -1, -14, and 24. Okay, so we're going to drop the 1 below. -4 times 1 is -4. -1 times -4 is -5. We multiply. -4 times -5 is going to be 20. And then we add. -14 plus 20 is 6. And then we multiply. -24 and then 0. So that shows that it is a factor. Let's see. Our depressed polynomial here is x squared minus 5x plus 6. So we want numbers that multiply to 6 and add to -5. I'm actually going to write this over here. So x squared minus 5x plus 6. Okay. So this time we want multiply to +6, add to -2. This time it would be -2 and -3 because multiplied would be +6, add, and you'd get -5. So now for our factored form, we have f of x equals x plus 4 from the original, the given. I keep calling it original. I guess that's the same thing. X minus 2 and then x minus 3. And then our zeros are going to be -4, 2, and 3. And so that's it. Hopefully you find this easy. The factoring is the hardest part, but since we've been doing so much factoring lately, I think that you guys will think it's pretty easy. But if not, please let me know and we can go over it during Act Lab. Okay, that's it. Have a great day.